Welcome back, future electricians and lighting professionals. Today, we're diving into a fundamental topic that's becoming more important every year, the basics of LED or light emitting diodes. Why are we talking about this? Well, LEDs are quickly becoming the most dominant lighting technology in homes, businesses, cars, streetlights, you name it. If you're studying electrical systems, understanding LEDs is a must. So let's get into what they are, the different types, why they're so popular, and what makes them different from all older lighting technologies. The reason this topic matters is because lighting world has changed. We moved from incandescent and fluorescent lighting to solid-state lighting, and that means LEDs. But here's the thing, LEDs are not just better bulbs, quote unquote. They are a completely different kind of technology, and if you're going to install, troubleshoot, or design lighting systems, you need to understand how they work and how to choose the right one for the job. Let's start with the two basic types of LEDs you'll come across. There are indicator type LEDs and illuminator type LEDs. Let's break those down. First, the indicator type LEDs. These are small, low power LEDs you've probably seen in electronics, like the power light on your TV, your game controller, or your dashboard lights in your car. They are used to indicate status, on or off, charging, warnings, not to light up a room. They don't produce a lot of heat and they are very energy efficient, but they are not designed to illuminate spaces. So think of them as signal lights, not actual lighting. And two, we have illuminator type LEDs. These are the real workhorses, also called high brightness LEDs, high power LEDs, or surface mount LEDs, because they are mounted on a flat surface. These are built to replace traditional lighting, like incandescent bulbs, halogen floodlights, or even high-intensity discharge lamps. They are powerful, bright, and very efficient, but they also create more heat than indicator LEDs. That's why they require proper thermal management, like heat sinks or specially designed housings that lets heat escape safely. In short, these LEDs are designed for functional lighting, to light up a room, street, building, or workspace. Heat is a big deal in LED design. Even though LEDs don't get as hot as incandescent bulbs, too much heat can still damage them and shorten their lifespan. So when you're working with illuminator type LEDs, you need to make sure there's good thermal path, a way for heat to move away from the LED. That's why LEDs are often surface mounted to metal boards or housed in fixtures with built-in heat sinks. Now, here's something that sets LED lighting apart from traditional lighting. LED lighting systems are usually custom designed for their space. Why? Because LEDs are directional. They shine light in a specific direction instead of everywhere at once. That gives us more control, but it also means we need to plan carefully. That's why lighting designers use photometric layouts. They take light measurements, create diagrams, and use software to figure out the best placement and fixture type. The result is more even lighting, fewer hot spots, better energy efficiency, and a cleaner, more professional appearance. So, even though LEDs are easy to install, design still matters, especially in commercial and architectural settings. When evaluating or comparing LED systems, here are key performance specs you need to understand. Total light output. Measured in lumens, this tells you how much light is produced. Efficacy. That's lumens per watt. How efficient is the LED at turning electricity into light? Color quality, which includes color temperature, measured in kelvins, think warm or cool light. CRI, color rendering index, how well it shows colors. Color consistency, how close the light color is across multiple fixtures. Rated life, how long the LED is expected to last in hours. Light distribution, is the light focused, diffused, or spread out? This depends on the optic or reflector used. Now, let's talk about why everyone is switching to LEDs. Here are some of the biggest benefits. High brightness and intensity, great visibility with lower energy use. Efficient, less wasted energy, low electricity bills. Low voltage, safer to use in many applications. Minimal heat, safer and longer lasting. Highly reliable, fewer failures, especially in tough environments. No ultraviolet light, safe for art, fabrics, and sensitive materials. Instant on, no warm-up time needed. Dimmable, works well with control systems. Mercury-free, better for the environment. Can be cycled on and off without damage, unlike fluorescent. All these add up to lower total costs of ownership, less energy, less maintenance, and fewer replacements. As someone training to enter the electrical field, here's what you should remember. LEDs are different from traditional lighting. They're electronic, not gas or a filament based. You need to consider heat management, optics, and system design. Understanding specs like lumen output, efficacy, and color rendering will help you pick the right product for the job. LED retrofits are a big part of today's electrical work, so knowing how to replace older systems with LEDs is a valuable skill. LEDs aren't just the future of lighting, they are the present. And understanding how they work, what types exist, and how to design around them is essential for everyone working in the electrical trade. Whether you're planning new installations, retrofitting old fixtures, or simply helping customers choose the best lighting, your knowledge of LED basics sets you apart. Thanks for listening, and keep up the great work as you grow in your skills in the electrical field. We'll see you next time for another lesson on lighting systems and technologies. Until then, stay safe, stay curious, and stay bright.